Welcome to lesson 4 of looking at internet and web fundamentals. In this lesson, we are going to look at some of the networking services such as dynamic host control protocol, routing and remote access services, internet protocol security, network type protocol, and voice over internet. Good people, this is the fourth video in my series where I'm teaching about internet and web fundamentals. I've also shared the link to the comprehensive article about this lesson in this video description. Just to let you know, in the last video I talked about understanding internet protocol and how to categorize IP version 4. I've also shared the link to the video in this video description. My name is Anwar Mulombe from Mulan Technologies. If you have not subscribed to my channel, kindly do so. Hit that notification bell icon to receive instant updates whenever I upload a video in the coming days. Leave your comment below in the comment sections and share this video to help your friends know about it. Let us start. Dynamic Host Control Protocol, that's DHCP, is a client-server network management protocol that automatically assigns an IP address and other related configuration informations such as subnet mask and default gateway to the nodes or devices connected to a network. This technology eliminates the need for individually configuring network devices manually, and it consists of two network components. Number one, a centrally installed network DHCP server and client instances of the protocol stack on each computer or device. Guys, the DHCP server maintains a pool of IP addresses and leases an address to any DHCP-enabled client when it starts up on the network. Because the IP addresses are dynamic rather than static, addresses that are no longer in use are automatically returned to the pool for reallocation. When connected to the network and periodically thereafter, a client requests a set of parameters from the server using DHCP. For example, within a local area network, a DHCP server assigns a local IP address to each device. Depending on the implementation, the DHCP server may have three methods for allocating IP addresses. Number one, dynamic allocation, where a network administrator reserves a range of IP addresses for DHCP, and each client on the LAN is configured to request an IP address from the client server during network initialization. Number two is automatic allocation. This is where the DHCP server permanently assigns an IP address to a requesting client from a range defined by an administrator. The server keeps a table of past IP addresses assignments so that it can preferentially assign to a client the same IP address that the client previously had. Then the last method of allocation is manual allocation, where an administrator maps a unique identifier such as MAC address for each client to an IP address, which is offered to the requesting client. DHCP servers may be configured to fall back to other methods if this one failed. Remote access services, abbreviated as RRAS, is grouping of different hardware and software platforms to allow remote access to another computer or network device. Microsoft RRAS has morphed into routing and remote access service, that's RRAS, This powerful service allows clients to connect remotely to a central network using dial-up and high-speed internet connection. RRAS provides a remote user with access to an internal network via a secured private network, that's VPN connection. This connectivity can be deployed using typical IP-based VPN over the internet, or like an internet service provider as ISP. It can be deployed through a dial-up services by allowing remote users to connect with organizational network after authentication. RRAS also supports site-to-site connectivity between two different remote servers. Internet Protocol Security, that is IPSec, is a protocol within the TCP IP suites that encrypts and authenticates IP packets. It's designed to secure any application traffic because it resides on the network layer or the internet layer, as TCP IP programmers refer to it. This program is used in conjunction with virtual private network and is an integral part of IP version 6. IP packets lack effective security mechanism and may be forged, stolen, or tampered with when being transmitted on a public network such as the internet. To solve this problem, the communicating parties establish an IPSec tunnel for encrypted transmission of IP packets. This ensures secure transmission of IP packets on an insecure network such as the internet. Guys, there are three main protocols that IPSec uses to perform its necessary function. Number one is security association, which generates the encryption and authentication keys that are used by IPSec. Number two is authentication header that provides connectionless integrity and authentication of data. It also provides protection versus replay attacks. Number three, encapsulating security payload, which provides the same service as authentication header but also provides confidentiality when sending data. From what we have just seen, IPSec is therefore a framework that helps us to protect IP traffic on the network layer. Why? Because the IP protocol itself does not have any security features at all. IPSec can protect your traffic with using confidentiality, that's integrity, authentication, and anti-replay, which allows it not to transmit any duplicate packets. IPSec protects point-to-point communication by establishing secure tunnels between host and network security gateways, or between network security gateways such as routers and firewalls. It operates at the IP layer to encrypt and authenticate data packets. Compared with other VPN technologies, IPSec VPN is more secure because its data is encrypted in transmission tunnel. However, the configuration and network deployment of IPSec VPN are more complex. Then, Network Time Protocol, that's NTP, is a protocol that allows the synchronization of system clocks, that's from desktop to servers. Having synchronized clocks is not only convenient but required for many distributed applications. Accurate time for all devices on a computer network is important for many reasons. A discrepancy of even a fraction of a second can cause problems. Some example of NTP, of how NTP is used are the following. Number 1, distributed procedures depend on coordinated times to ensure proper sequences are followed. Number 2, security mechanisms depend on consistent timekeeping across the network. Number 3, file system updates carried out across several computers depend on synchronized clock times. Then the last point, network acceleration and network management system rely on the accuracy of timestamps to measure performance and troubleshooting problems. Then the last service is what is called Voice over Internet Protocol, that's VoIP. This is a technology that allows you to make voice calls using broadband internet connection instead of a regular or analog phone line. Some VoIP services may only allow you to call other people using same services, but others may allow you to call anyone who has a telephone number, including local, long distance, mobile, and international numbers. Also, while some VoIP services only work over your computer or special VoIP phone, other services allow you to use a traditional phone connected to a VoIP adapter. VoIP services convert your voice into a digital signal that travels over the internet. If you are calling a regular phone number, the signal is converted to a regular telephone signal before it reaches the destination. In addition, wireless, that's the hotspot, in locations such as airports, parks, caves, allow you to connect to the internet and may enable you to use VoIP services wirelessly. Good people, thank you so much for watching. In the next video, I'll be talking about packet switching and routing as part of wide area network. See you there. Thank you so much for watching. God bless you.